All right, next lesson. Graphing linear inequality. So if you think about graphing lines, that was all grade 10. That's just about all you did is graphing lines, and you did it several different ways. If you remember, we used table of values, we used the two-intercept method, and we used the slope-intercept method. I'm going to review two of the methods with you. I don't think you should use table of values, but you should know how to do slope-intercept method. All right, let's do that first. So the equation is 4x plus 3y equals 12. What's slope-intercept method? That's slope-intercept method is y equals mx plus b. So we got to change this equation so it looks like that. So let's take the 4x over to the other side. It becomes negative 4x. And then if I divide everything by 3, I end up with y equals negative 4/3 x plus 4. So this has a y-intercept of 4 and a slope of negative 4/3. So let's try and graph that. So y-intercept is 4, and the slope is negative 4/3. So rise negative 4, that's down negative 4, and then over 3. And there is our line. Okay? Now, that was one method. That's a good method. I actually kind of like the two-intercept method better. And the reason I like the two-intercept method better, if you think about parabolas, what did I say you always need to graph? You need the two intercepts. You need the x-intercepts and the y-intercepts. So the two-intercept method will get us that. Now in this case, you can see that we actually have the y-intercept and the x-intercept, but it's not always going to happen that way. So to get the two intercepts, you're going to find the x-intercept and the y-intercept. How do you find the x-intercept? You make y equals 0. So you'd have 4x plus 3 times 0 equals 12. So 4x is 12, x equals 3. And you've already got that plotted. Y-intercept, you would make x be 0. And so then you'd have 3y equals 12, y equals 4. And we also have that plotted. So those are the two methods. You should get used to using them both. I don't care which way you use, which method you use. It'll be kind of whatever's more convenient. Okay? So graphing a linear equation, we just did that. If we replace the equation, the equality, with an inequality, you get a linear inequality. And we want to be able to graph those. Okay, so what does that look like? Well, maybe this will help a little bit. If I want a job that pays more than $9.50, what would be an example of something that gets more than $9.50? Well, $10 would be more. So anything above this line would satisfy more than $9.50. But what is a job that pays at least $9.50? Well, the difference there is $9.50 is included. So if it's included, what do we do that's different? We use a solid line for included. Okay, so dotted line if we're not including $9.50, solid line if we are including $9.50. All right, and that explains that here. Now the question is where to shade. Well, generally speaking, we shade above if it's greater than, and below if it's less than. But you'll see sometimes that's not perfectly obvious. So let's try a question. Okay, we're supposed to graph this inequality. Well, what do you want to do? The two-intercept method or slope-intercept method? Well, let's try this with the two-intercept method, and I'm doing that because that way I don't have to manipulate the equation. I can just work with it exactly like it is. So I have negative x minus y, and I want to know when does it equal 6 to find the x-intercept. Okay, to find the x-intercept, you're going to make y be 0. So you get negative x is 6, x is negative 6. Same with the y-intercept. So you have the equation. I'm going to make x be 0, And so you get negative y is 6, and again y is negative 6. So I'm going to plot those two values. X is negative 6. That's right here. And y is negative 6. Right there. So if I was drawing the line, I would just connect the dots. But I'm not drawing a line. I'm looking for where is this graph greater than 6, not equal to. So I'm going to start by drawing a dotted line. All right, that's because it's not equal to 6. Now the question is, do I shade above the line or do I shade below the line? Well, to me this is not obvious. It's not obvious whether I should shade above or below. So I'm going to do a test point. Okay, and usually the test point is 0, 0. That's this point right here. And it's easiest to use that. That's why I'm going to pick 0, 0. What I want to do is I want to put it into this equation and see if the statement is true then. So, negative 0 take away 0. This is 0. Is 0 greater than 6? Well, no. 0 is not greater than 6. This is not true. This tells me this point doesn't work in the inequality. So that means I want to shade on the other side of the line. All right? And I mean, I could pick another point. I could go and pick this point to see if it works, but I don't need to. As soon as you see that one doesn't work, then everything has to be on the other side of the inequality. Okay? Let's try another one. Let's do this one with slope-intercept method instead, just so that we get used to using both. Okay? So I'm going to change this to slope-intercept method, or form, I guess I should say. So I'm going to leave the y on this side. I'm going to bring the 2x to the other side. It becomes positive. The 11 becomes negative. And then I'm going to divide by negative 3. And remember, if you divide by negative, what happens when you divide by negative? The inequality switches direction. So you have negative 2/3 x plus 11/3. Okay, and this gives us a y-intercept of 11/3, and it gives us a slope at negative 2/3. Okay? Now that's not really nice. It's not a really friendly one. Okay? So let's just take a look what happens. So you would put a y-intercept of 11/3. Now the problem is, how do I go down 2 and over 3? This is ugly. It's going to be fractions. So maybe this is not a good method here. Maybe I would be better off just finding the x-intercept, and then I would know how to graph this line. So I'm actually going to say, let's scrap this method, and let's do it with an x-intercept and the y-intercept. Now I already know what the y-intercept is, but let's just do it anyways. So negative 2x minus 3 times 0 plus 11 equals to 0. So negative 2x equals negative 11. X is 11 over 2. And we already did this. If I go y-intercept, so negative 3y is negative 11. Y is 11/3. Okay, so I have that. 11/2 is bigger, so I'm going to make it look like it's a little farther. And I want to connect those dots. Should I use a solid line or a dotted line? Should be dotted because it's not equal to. Okay. Now, where to shade? Well, if I look back to what I crossed off here, I want less than this. So that kind of tells me I think I'm shading this way. But again, I'd like to check. I would like to check a point, and I'm going to check 0, 0 again. So is 2 times 0 minus 3 times 0 plus 11, is it greater than 0? Is 11 greater than 0? Yes. This tells me this point, 0, 0, is in the solution. It works. So I will shade down. Okay? Determine whether each point is the solution. So this is just saying, does this point work in this equation? These are really simple questions to do. All you do is plug in the values and you say, is it true or isn't it? So is 8 minus 3 less than or equal to 5? Is 5 less than or equal to 5? Yes. That one is a solution. Okay, 4 times 2 minus 5, is that less than or equal to 5? Is 8 minus 5 less than or equal to 5? Yes, it is. Because 3 is less than 5. Okay, let's try this one. 4 times negative 1 minus 1, is that less than or equal to 5? Well, this is negative 4. This is negative 5. Is that less than or equal to 5? Yes. Let's try this one. Is 12 minus 1 less than or equal to 5? No, that one doesn't work. Okay. And I think this is, last example here. Write an inequality to describe each graph. So now we're supposed to do the other way around. I gave you the equation and I asked you to graph it. Now I would like you to give me this equation. Okay? Now there's a number of ways to do this, but I think the easiest way is to use slope-intercept method, because I can see what the y-intercept is, and I can figure out what the slope is pretty easily. To find the slope, I should find another place where two lines meet. Okay, and if I go here, it looks like I know what that point is. So this tells me the y-intercept is 2, and the slope, remember slope is rise over run. What did this rise? 3, and what did it run? 1. So I can write this inequality. Well, first, just put this equals for a second. So this is 3x plus 2, but it's not equal to. It's either less than or greater than. Not equal to because there's a dotted line. Do you think it's greater than or less than? I think it's greater than because it's above the line. It's above the line y equals 3x plus 2. If you're not sure, you could check. If you put 0, 0 in, is 0 greater than 2? No, it is not. This is not a solution, so that's good. 0, 0 doesn't work, so it's not in the solution. Okay, let's check this one out. Take a second to try it. All right, again, these aren't supposed to be tricks. You should be able to see pretty easily what the points are. So there looks like the y-intercept is negative 2. What's the slope? Where is the obvious point? I think that looks like an obvious point. Okay, I don't like this one. This one doesn't look like it's right, so I'm going to pick this point. What is the run? Looks like the run is 5. And what is the, sorry, that's the rise. What's the run? Looks like negative 1. So slope is negative 5 over 1. Well, that's not really what we have. We have 5 over negative 1, which is negative 5. So my inequality will be y something negative 5x minus 2. What should go here? Is it less than? Greater than? Well, it should be one of these two, right? Because this time it's a solid line. What is it? Well, it looks to me, if you look at this line, all right, we are less than the line. We're below the line. So if it's below, I think it's going to be less than or equal to. All right? So, homework. Should be page 360, numbers 3 to 9, 10, 11, 12, 16. All right.